All right, in this video, I want to help you out with the assignment for 0305. And I'm going to do that by just going to my grade report. This is the quickest way to get to your assignments and see what's due. And I'll just come down here to 0305, re-expressing data. And this project is a little complicated, so I wanted to make a video just going through this. And I'll start by reading the directions. You must make a copy of this template and then download it as a PDF when finished. So here's the template. We'll submit the PDF. Here's an attachment. And please, no links, no other files. Don't submit anything like that. I cannot accept that. Don't type your assignment in here in the box. I cannot accept that either. It really does need to be this PDF that you've downloaded and submitted here. And I'll start that by opening this link. It's going to tell me to make a copy of the template, which I will do. And again, here's the directions again. Make a copy of this, download it as a PDF when we're done, and then we'll come back and submit it into the assignment. So first of all, you will start just by typing your name into here. Tell me which period you are in. And I'll start us off with a question. Here I'm saying, what is a residual in statistics? And please answer in your own words. So let me help you out here. If you think back to the assignment before this, we had a question like this that was showing the price of donuts versus the total cost versus the total number of donuts. And it gave you a line of best fit. This was our predicted values. Here was this line. And then our actual values were these scattered dots. So you could think of a residual as kind of that distance between the dot and the line. Or you could say, what's the difference between the expected value and the actual value? A low residual, like this dot is very close to the line. So here the model is doing a good job of predicting this data point. This has a low residual. Or this one over here, this has a higher residual. It's pretty far away from the line. So we would say that this one is not very well predicted by the model. I hope that helps. But again, you just want to answer that in your own words here. So type something. Type something like that here in your own words. For the next part, this is from the slides in your table of contents, but I copied it here just so we're not flipping back and forth. This says Regional Rent-A-Car is interested in studying how weight of a vehicle is related to the fuel efficiency for several of its rental vehicles, and a random sample of 13 vehicles from Regional Rent-A-Car yielded this data in the table. So they are recording the weight of each car in pounds and its fuel efficiency in miles per gallon. So our next step is going to be to create a new Google Sheet, and we're going to enter this data into those cells. And this is going to be a lot easier than doing this by hand. Let's go ahead and do that. I'm just going to click New Google Sheet. And the best way to do this is just open this in a different window, kind of side by side, just so that we're not flipping back and forth. It makes it a lot easier to type this in. And we're going to do this because this spreadsheet is going to do most of the work for us. There we go. We're going to make the spreadsheet do most of the work for us, because if we're doing this by hand, it's going to take a very long time. So let's begin by just typing in these weights. So first was 2000. I've got 3123, 3775, 2287. Okay, so we have our data typed into the spreadsheet now, and I just want to check this for mistakes, make sure I didn't enter anything wrong. So I can scroll down here and I can click this. Done. I've created a new Google Sheet. And now I can start to answer the questions. So the first part A, is identify and interpret in context the estimate of the slope for the least squares regression line. And the way I'm going to do that is, let's see, let's make this bigger. Let's start by making a chart. And I'm just going to select all my data here, go up to insert chart. And I do want to make a scatter chart. So if this is on, a bar graph or a line graph, make sure it's on scatter chart or it's not going to work for us. And I can bring that over here. Let me shrink that down a little bit. All right, that should be good. And next I'm going to go to customize series, and you can change the colors here if you want to. You can change the shapes. But what I really want is the trend line. So this is going to do the line of best fit for me. Again, I can change that color if I want to. And the other thing that I want to check, so I've got trend line. I also want this R squared value. And this is going to calculate my R squared value for me. Or we could say R coefficient. So next I'm going to use the line ST function right here in Google Sheets, and this is going to do the line of best fit for me. So this, first I need to begin with the known data for the Y's. That is from B2 down to B14. Known data for the X's is from A2 to A14. It's going to be this column over here. Close the parentheses, and this will calculate that for me. So what this has done, this has given me the slope right there, and this would be our y-intercept over here. All right, so that's going to save us a lot of time. So right away, I've already got the slope, I've got the y-intercept, and over here I've got the R squared value. This is going to save us a lot of time. So coming back over to here, what was the slope? There we go. I could tell the slope was this number, negative 0.007. You could select that. And what does this mean? Well, for each additional 1 pound, or you could say every extra 1 pound, either way, vehicle weight, the fuel efficiency is predicted to decrease by 0.007. And I can tell that's decreased because of this negative sign. All right, for the next part, part B says identify, interpret in context the correlation coefficient. And I gave you a hint, make a chart and then square root the R squared value. So this is already done. Here we go. This has already done that R squared value. This is 0.891. Our correlation coefficient is from this just by square rooting that number. So if I do 0.891 and I click the square root button, this gives me, so this is going to be negative 0.944. Notice that it's negative because the slope of the line is negative, or the correlation is negative. It's going down. But when I square this number, it does become positive. So just be careful with that. We will end up with a negative there. And then this tells us that there is a strong negative relationship between the weight and the fuel efficiency of these vehicles. So again, I know it's negative because of this negative sign, also because the line is going down. And it's strong because this number is close to 1. This is a very high R value. If this was something like, 0.002 or 0.1, something very low, that would be a weak relationship, but this is close to 1, so it is stronger relationship. All right, for the next part, part C, a car weighing 2,684 pounds had average fuel efficiency of 24.6 miles per gallon. What is this car's residual? So let's go ahead and calculate our line of best fit here. So we're going to say y hat equals, this is y with that little symbol on top. And this is going to be, let's just say 45.47. So I'm just rounding this number, minus 0.007. That was the slope. Again, I'm rounding that. That was the slope from up here. And the car has 2,684 pounds. So I'm going to multiply this times 2,684. All right. So you could do this on your calculator. You're just multiplying 2,684 times 0.007 and then subtract that from 45.47. A little bit of PEMDAS there for you. And when you do that, you should get 26.682. Is that not typing? There we go. 26.682. All right, so this would be our answer. Again, we're going to type pretty much everything that I just said and the answer into here. And again, answer this in your own words. All right, so don't just type out exactly what I said. Kind of put that into your own language, again, so that this doesn't get flagged for academic integrity. For the second part, so here it's saying, what is this car's residual? To calculate that, we are subtracting actual minus predicted. That's our formula for this, actual minus predicted. So for part D, this says estimate the weight of a vehicle whose fuel efficiency is 20.2 miles per gallon. And so again, I'm going to use my y hat formula here that we came up with. So y hat is 20.2, right? The fuel efficiency is the y. So here, let's say 20.2 is equal to the y-intercept, which was 45.47, minus the slope, which was 0.007, and then times the weight. All right, so we're going to work backwards here to get that weight. I'm going to use some solving equations, some algebra here, add 45.47 to both sides, and then divide by that 0.007. And the answer for this I got was 3610. Oops. There we go. So 3,610 pounds would be our estimated weight. So again, answer that in your own words, explaining this answer. That was our answer. Next is part E. So is this model the best fit for the data? Explain your reasoning. If a transformation is required, what is the equation for the new model, and show your work. So this, again, this is going back to those slides that we had here. If you read through your slides for re-expressing data, we had a couple different transformations that we could use. I'm going to give you a hint here on this one. We want to use an exponential model. So even looking at this graph, the line does kind of look like it fits, but as we analyze that, your hint here would be no, this is not the best model for the data. So hint, no, not the best model. Even though this line, it appears to be close, check your residuals plot. They're not going to be as close of a fit as we want that to be. A better model. So again, let me say hint, A better model would be an exponential model. All right, so here, tell me what would that equation look like, or what kind of transformation would you do to make this a better model? All right, so there's 2 hints for you. Kind of fill in the rest of that as you see fit. Okay, and the last part here, part F, this one is probably the hardest question here. So part F says, using the transformation that you gave in part E, what would the new estimate for the fuel efficiency of a vehicle weighing 2,684 pounds, what would that be? So if you look back in part E, again, you should have your own answer here. I'll give you a hint. It's going to be an exponential model, but you should have your own equation there. And what effect did this new model have on the residual compared to the result you found in part C? So go back to part C, look at what you had written for this, and we're going to compare these 2 answers. All right, so again, let me give you a hint here. We would say a new estimate for vehicle, something like this, weighing 2,684 pounds. And again, you're going to have a different equation here. You should not be using my same exact equation, my same exact numbers. We're all going to have different numbers here, just slightly. So even if you're working with another student, make sure you guys have different equations here. You should have something kind of like 162. Here we go. This will be times 0. Let's say 9783. There we go. All right, and again, you're not going to have these same exact numbers. You'll get these from your exponential model. And we're going to raise this to the power. This is exponential. Your exponent is going to be 2684. So that is just this number here. And see what you get for that. All right. I'm getting something like 25.559 if I round here. And again, you're going to have a different answer, so you should not have the same exact number. But I'm going to use this to calculate my new residual. So my new residual is going to be, let's see, it was 24.6. And then I'm going to subtract my new value, which was 25.559. So we'll subtract that. Again, I am just using this formula. It's actual minus predicted to calculate that. And I could do that on my calculator. So for me, I'm doing 24.6 minus 25.559. And my number is negative 0.959. So again, you'll have something different here, but hopefully close to that number. The absolute value for this is just dropping that negative sign, so 0.959. So here, take a look at that absolute value. Is it smaller than your previous residual? Again, going back here, looking at part C, look at what we had for part C. So is this smaller? Is it larger than the previous residual? Is that better? If it is, then your new model did a better job of predicting the fuel efficiency of the vehicle. If it's not smaller, then it did not do a better job. So again, I will say answer this in your own words. So I kind of did give you the answer here. Just don't type exactly what I said. Put it into your own words. Again, your numbers here will be different than mine. This number should be different than mine. Same with this as you use that exponential model. I'll just say one last time, it's okay to get help. It's okay to work together. Just make sure that you have answered everything in your own words and you have your own equations. Your last step for this is you just go to File, download this as a PDF once you're all finished. I don't need your Excel spreadsheet. That was just to show you how to do it. And I hope those steps made sense because you will be using that some more in this module. Your last step, you just want to click Choose File and you will upload that PDF here. And you can submit this for grading when you're ready. All right. This one is a very tough assignment. It's definitely very complicated, a lot of steps, but I hope that this helped you out and good luck in your course.